So, now we have the basics of Lewis diagrams down. We sometimes run into the question of how we decide when there are multiple equivalent structures, how we decide which structure is correct. And so we're going to walk through the process today of determining formal charge and using formal charge to help us determine which Lewis diagram is more technically correct. So, we're going to address the formal charge. And so if we want to use formal charge, we have to know how to calculate formal by first determining the number of valence electrons in our atom. We find the number of electrons that we've assigned by first counting the number of electrons in lone pairs, and then counting the number of electrons in bonding pairs attached to that atom and taking half of that number. Another way of looking at this is counting the number of electrons in lone pairs on the atom and then counting the number of bonds on that atom, which is the same thing as half the number of electrons. So let's take an example. So we're going to work with the okay, so CH2O, we have 4 valence electrons in carbon, and we have 2 hydrogens, which each have 1 valence electron, and then we have 1 oxygen with 6 valence electrons. And so that gives us a total of 12 valence electrons. So we're going to take the carbon and we're going to put it in the middle, but we have a lot of atoms here that we could attach to this carbon. So we could try attaching oxygen and then putting 1 hydrogen on each end, like this. So I've now used up 2, 4, 6 valence electrons, which leaves me with 6 more. So I'm going to put 2 here, and I'm going to put the other 2 here, and then we're going to put 2 valence electrons on carbon. And that's going to use up all of our valence electrons. Now we can see that that does not satisfy the octet on carbon, so we're going to take that lone pair and we're going to make it a double bond. Now we've used 2, 4, 6, 8, 10, 12 valence electrons, and we have a satisfied octet on all of our atoms. Now, we could do this a different way. We could try putting both hydrogens on the carbon, and then the oxygen, and we would attach these with bonds again as before, 2, 4, 6, and again I have 6 valence electrons left, 2, 4. Now I could start to put these 2 here, but I can see that carbon's octet is not going to be filled, so I make a double bond. So now carbon's octet is filled and oxygen's octet is filled. Both of these are valid and nearly equivalent Lewis structures. Let's try one more. We can put the carbon and oxygen, and we can put both hydrogens on the oxygen. We're going to connect with bonds, so I've used up 6, 8, 10, and again, if I add those 2 here, I can see that oxygen is not going to have a filled octet, so I'm going to go ahead and make that double bond. So, we have 3 valid structures here. How do we decide which one is correct? This is where we're going to consider formal charge. So first thing we're going to do is determine the number of valence electrons on each atom. So we know that carbon has 4 valence electrons, and oxygen has 6 valence electrons, and each hydrogen has 1 valence electron. Now we're going to count the number of electrons that are assigned to these atoms according to our Lewis diagram. So we have 1, 2, 3, 4, and then we have 4 that are being split between the carbon and the oxygen, so we're going to call that 2, or we could count each bond as 1, 1, 2. So we have 6 here, so we have 4 minus 6 assigned to it. For oxygen, it has 4 bonding pairs, which is a total of 8 bonding electrons, and we're going to have that for 6 minus 4. Hydrogen is sharing this pair with oxygen, so minus 1, And again, hydrogen is sharing this pair with oxygen, so -1. So that gives each of the hydrogens a formal charge of 0, but it gives the oxygen a formal charge of +2, and the carbon a formal charge of -2. Now, our formal charge rules tell us that the most accurate or most representative Lewis diagram is going to be the one that has the most 0 formal charges, and if that's not possible, it's the one where the negative formal charge is assigned to the most electronegative atom. So here we can see that we don't have 0 formal charges on either oxygen or carbon, and we can see that the carbon is assigned a -2 formal charge, whereas oxygen has a +2 formal charge. And we know that oxygen is the more electronegative element. So this is probably not a good choice, but let's see what our other options are. So once again, this has 1 valence electron, this has 4, oxygen has 6, and hydrogen has 1. And again, this hydrogen has 1 pair, so -1. Carbon has 1, 2, and I'm going to count pairs, 3, 4, 5, so 4 minus 5. 1, 2, 3, 4, 5, so 6 minus 5, and 1 minus 1. So we have a -1 formal charge on carbon, and a +1 formal charge on oxygen, and then we have, again, 0 formal charges on the hydrogen. So, again, we have our more electronegative element assigned a positive formal charge, so again, probably not a good choice. Better than the one above because it's a smaller formal charge, but still probably not a particularly good choice. So let's look at our last option here. I'm going to go around and assign valence electrons. And again, hydrogen is sharing a bond with carbon, -1. Hydrogen sharing a bond with carbon, -1. Carbon has 1, 2, 3, 4 bonds, so -4. So this gives us a formal charge of 0. And oxygen has 1, 2, 3, 4, 5, 6. 6 minus 6 gives us a formal charge of 0. And so this is going to be our most representative Lewis diagram. And that's how we're going to make those sorts of decisions. So let's look at another example. And that example is going to be NOH3. So we have NOH3. Okay, and so we're going to first count valence electrons, 5, 6, 3 times 1, so I have 11 and 3 gives me 14 valence electrons. So I know that I have nitrogen, oxygen, and 3 hydrogens. So I'm going to start out NO, and let's try putting those 3 hydrogens around the oxygen. And if we do that, then we make 1, 2, 3, 4 bonds. So I've used up 8 electrons, and I have 6 remaining. And that's a valid Lewis diagram. Oxygen doesn't often make 4 bonds, so I'm going to see if I can approach this in a different way. So I'm going to put the nitrogen here, I'm going to put the oxygen here, I'm going to put a hydrogen here, and a hydrogen here. That leaves me 1 more hydrogen, so I'm going to put it here. That's still a little excessive for oxygen in its normal state, but we'll see how this works out. So I've used up 2, 4, 6, 8 of my electrons. I have 6 remaining. 2. Now I have 2 remaining. Did I do that right? 2, 4, 6, 8, 10, 12, 14. Yes. Okay, so we have another valid Lewis structure here. We could try this way. We can put nitrogen here, oxygen here, and we can attach the 2 hydrogens to nitrogen and just 1 hydrogen to oxygen. Now I've used up 2, 4, 6, 8, and again I have 6 left. So I'm going to put them here. And there is yet one more option that we could draw, which would be to put all 3 hydrogens on the nitrogen. Okay, again I've used up 8, 10, 12, 14. So I have 4 valid Lewis structures. How do I decide which one is correct? Well, back to formal charge. So in this first one, 5, 6, and at this point hopefully you're starting to see the pattern that the hydrogens are pretty much always going to have a formal charge of 0 because they have 1 valence electron and they always form 1 bond. So we're going to focus only on the nitrogen and the oxygen. So in this structure, nitrogen has 1, 2, 3, 4, 5, 6, 7 assigned electrons. So this is going to be -2. Oxygen has 1, 2, 3, 4 assigned electrons. So this is going to be +2. Well, oxygen's more electronegative than nitrogen, so this is probably not a good choice. Let's check this one out. So again, we have 5 and 6. We have 1, 2, 3, 4, 5, 6 electrons assigned to nitrogen. So we're going to subtract that 6. And we have 1, 2, 3, 4, 5 electrons assigned to oxygen, so we're going to subtract that 5. This is better. Oxygen's +1 and nitrogen's -1, but we still have non-zero formal charges, and we have the more electronegative atom having a positive formal charge. One more example. 2 more examples, sorry. We have 6 and we have 5, and this time nitrogen has 1, 2, 3, 4 electrons assigned to it, so this becomes a +1, and oxygen has 1, 2, 3, 4, 5, 6, 7 electrons assigned to it, so it's going to be a -1. That's better. Now our more electronegative atom is assigned a negative formal charge, and our less electronegative atom is assigned a positive formal charge. But we do have one more to assess. So again, 5 and 6, and nitrogen is 1, 2, 3, 4, 5 valence electrons, or 5 electrons assigned to it, and oxygen has 1, 2, 3, 4, 5, 6 electrons assigned to it, and that gives everything in this structure a formal charge of 0, so this is going to be our best choice. I hope that helps with formal charge. If you have any questions, let me know.